So, thanks. It's my privilege once again to welcome you all to this, what we're now calling the Sundowner Webinar Series. And again, just to reiterate what we said at the last webinar, after we had quite a successful online virtual conference in July, we decided to start this webinar series just to allow members and also non-members of the society to just interact on a scientific level and exchange information. And we started off with Alan Knapp last week giving a really interesting talk. That was very successful. And so we're back this week again with Sam Fuhlendorf. Now, Sam is no stranger to many of us in the Grassland Society. He has attended, I think, at least 2 of our congresses before, and has been a very popular speaker at those congresses. Now, I'm not going to go through Sam's bio because it was in the information that you've all received to advertise the conference. I think one of the most interesting things about Sam, though, is that he comes from a place called Stillwater. And that kind of implies that nothing much happens in Stillwater. But obviously, having listened to Sam before and read some of his papers, obviously quite a lot does happen in Stillwater. So, Sam, we look forward to hearing you tell us about animals, fences, and fires, heterogeneity, and grassland management. Thank you very much, Sam. Thanks for agreeing to come and talk to us, and over to you.
Thank you. It's my pleasure to be here. I guess I will go ahead and see if I can share my screen so that make sure everything works. Let's see, do it this way. Okay, is that working?
Yes, that looks great. Thank you, Sam.
Okay, great. Thank you, Kevin. I'm glad to be here. I really enjoy all the interactions I've had with the Grassland Society, and I'm happy to be here and have the opportunity to be a part of this. Kevin mentioned Stillwater, and Stillwater is under our university is shut down today, not because of COVID, but because of we had this strange climate event where we still have green leaves and actively growing trees, but we had a severe freeze with lots of rain yesterday. So I was planning on spending more time on this beforehand, but for the past 24 hours, my family has been staying here because half of us are without electricity. So I'm glad to be here, and I'm glad my electricity works. So one of the challenges of talking again here is that I've talked twice at the Grassland Congress, and I don't want to exactly talk about the same thing. So there's going to be some overlap because I assume there would be some people here that I haven't heard me before, but I try to present some new version of this, and hopefully I'll end with some logical points that we can discuss because I've learned as much from my interactions as anyone, so I look forward to it. We live in a unique time where we have a lot of misinformation on the internet, and you can find all kinds of things. This is a site with a documentary that cows have caused every environmental ill imaginable, and clearly this is a flawed perspective, but I will say it's not entirely wrong, just like any perspective. But at the same time, if you Google around a little bit, you can find examples where you can find the opposite, where cows can save the world. So, so I would suggest it's a good time for us to talk about the science associated with this. And I have a tendency to want to talk about peer-reviewed science, but in general, all of those discussions are relevant because we have an increased demand of meat, and that's not all beef, but a lot of it is, and this is happening across much of the world, and projections are that it will continue to happen, especially if you listen to some of the people in agriculture in the U.S. I'm not sure how long it will continue, but there hasn't been a decline in the demand for beef recently. Simultaneously, we have a demand for more ecosystem services on our grasslands or rangelands or whatever we want to call them. The bottom line is there's the millennium view is that essentially we're going to have increased demand on many of these aspects, including things like pollinators and biodiversity, as well as aesthetics and livestock production. So what I want to talk about today is, can rangelands or grasslands or grassy biomes answer an increased demand for meat production, and basically ask, how have we done so far, at least initially? And then I want to sort of use some of my research to speculate where we can go in the future. So one of the favorite things to do in the U.S. is make fun of Texas A&M University, which is, there's a lot of logical reasons to do that, but it does do some good research. And this is, I can say that because, or at least I can make jokes because I did get 2 degrees there, but the place I worked is the Sonora Experiment Station, and it's been around over 100 years now. And this graphic, I think, is very characteristic of a lot of long-term research stations. It does not show sustainable agriculture. It shows quite the opposite, actually. So what this shows is a 6-fold decline, or actually it's more than that, in livestock carried on the landscape of the Sonora Station. And there's a lot in this graphic, and I won't spend a lot of time on it, but initially it was an animal science station. And it was before there was even a rangeland profession. Nobody really knew even what a stocking rate was. So arguably they were very heavily stocked. By 1948, they had figured out that most of the animal health issues were associated with range management. And so they changed it, and you can see that it stabilized for a while. We had the drought of the 50s, but after that, it even increased the stocking rate, or the numbers of animals. But then it's continued to gradually decline. And so why is that? Well, the animal science focus was mostly on the animals, as you would expect. The range management focus was mostly focused on grazing management and grass. And all the while, we were going from a grassland or savanna to a closed canopy woodland. So we were focused on the animals or the grass, and next thing you knew, there wasn't any grass. So it didn't really matter what the animals needed or what the grass needed. The bottom line is we had a woodland. And so another way of looking at this is from a paper with Brad Wilcox recently, is that we went from a grassland to a woodland that's actually often much more dense than the D photograph. And we sort of decoupled fire and grazing that occurred in the first part and imposed very heavy grazing, as you'll see in the B picture, before we really did much management, and basically fireproofed the landscape. And since we have moderated the stocking rates, we've gotten a lot of the grass back and started restoring fire to the system, but oftentimes it requires a little bit more effort to get the system to go back in the other direction. So that's the context of this expansion of woody plants, and sort of the idea of forgetting to focus on the big picture because we're focused on managing the details of the animal-plant interaction. And so one of the things from my work with Brad Wilcox, and this should make any sociologist laugh in the audience, but ecologists tend to focus in this green box. And that's where I've always focused. And now we have what we call a socio-ecological perspective. And that just basically means that people matter. And it's interesting that ecologists are realizing that people matter. Most of the world already knew that. But in reality, when you start to think of the world as a socio-ecological system, it kind of changes the perspective of the kinds of questions that you might ask. And so the idea here is that you have the social domain over in the blue, and the way that humans interact with the ecological domain or the biophysical is through ecosystem services that provide benefits or negative actions to social domain, and then that eventually, through a series of complex interpretations, leads to what they apply on the landscape from a management standpoint. Also recognizing that the external drivers up top influence basically everything associated with that. But the idea is that this changes the way we can think about these topics and help us understand why people are doing management and not doing management. And so, generally speaking, if you focus on A here, the left side, the argument we would make is that, okay, ecologically, where do you have a grassland? And that's really important to understand. And a lot of good ecological research has been done to do that. And so on the top axis, you have low likelihood ecologically for a grassland all the way to high in the number 2 box. Vertically, you have the social willingness to maintain a grassland. And so it goes from low to high. And the point being that the only way you're going to have a grassland is to be in 4, where you actually have the social will as well as the ecological will to actually maintain the system. So when I look at some of our remnant grassland landscapes, I think the social willingness in some of those may be more at risk than the ecological willingness or the ecological conditions that are suitable. So from a social perspective, we can take this issue of fire suppression and woody plant encroachment, which most of the woody plant encroachment that I've discussed so far is at least associated with altered fire regimes. And we can actually ask, well, how does it affect people? And I'm just going to be brief here and provide a little bit of literature, but I'm happy to talk about it additionally. So I've already mentioned livestock production, and there's some good examples where limiting fire and allowing woody plant encroachment leads to lower livestock production. We have a lot of endangered species habitat, and there's a lot of good papers about that, that, you know, it's not a surprise that grassland species require grasslands. We also have some economically important wildlife like deer and quail that are used to supplement land management incomes. We've seen data that has water cycle alterations. If you don't like ecological things, maybe childhood asthma rates and pollen matter. So particularly in the US where we have juniper species increasing, we have increased pollen levels that have been associated with that and increased childhood asthma rates. Estelle Levitin from Tulsa has done a good job of studying that. We've also seen an increase in wildfire danger. And the picture in the bottom right there sort of shows a wildfire during a drought in Texas. And then finally, we've recently, and we actually just have a paper coming out in disease vector ecology that's about ticks expanding as we eliminate fire and have an encroachment of woody plants. We get an increase in the specific ticks that carry diseases that are important to humans. So the point is that we're having a major alteration across the landscape. Some of these affect the landowner individually, but some also affect broader society. Okay, so If woody plant expansion is one of the greatest threats to ecosystem services on grassy biomes, and in fact, we've argued that it's the greatest threat right now, how do we manage landscapes to limit woody plants and promote ecosystem services? So what do we need to do? Well, if we think about multiple ecosystem services, then the thing that I talked about at the last Congress I attended was the importance of heterogeneity, and this is included in a book chapter that's free online with that's in the Brisky et al. Book. The point of all of that is that we need heterogeneity, and I'm going to briefly talk about that here. But this is mostly what I talk about to my family and friends, which they don't like too much. But I'm happy to expound on that as much as you want. And then finally, how can we discuss typical rangeland management practices regarding this sort of heterogeneity? And by typical rangeland practices, it's actually the 4 propers that I always joke about that you're supposed to have tattooed on you when you get a degree in range science somewhere. But they're proper stocking rate, proper distribution in time, proper distribution in space, and then proper kind and class of animals. I call them the propers, and the problem is that the proper part isn't really well defined. So you have to understand what was meant by proper. And so if we take the most important one, the numbers of animals, and we create a gradient from no grazing to severe grazing, and I presented this last time. This is from a paper published in 2012. The way we've traditionally done range management or grassland management from a stocking rate standpoint is we know that gain per head is lowest under light stocking, gain per acre or hectare is best under heavy. And so this economic optimum is considered the proper, and it's right at moderate, even light to moderate in some cases. And so that traditionally has been viewed as also the ecological optimum. But in reality, if you actually start to develop this ecosystem services perspective, you find out that the proper stocking rate includes all of these conditions. And they basically, in order to have all of these ecosystem services, you have to have a landscape that includes everything from no grazing to severe grazing. And there's lots of examples of species that require the ends of the gradient as well. Okay, so you have to have, if you want all ecosystem services, you have to have a landscape that includes this. So how do we have heterogeneity and simultaneously limit the greatest threat to grassy biomes that we currently have, which is woody plant encroachment? There's a recent project funded by USDA that includes Brad Wilcox and others at Texas A&M and my group at Oklahoma State University and Drac Twidwell at Nebraska, where we've addressed that question. And we've argued that there's two solutions, and I'm going to talk briefly about one and a little more about the other because we know we're acquiring information on the combination of those two. But hopefully you'll hear more about the Prairie project as this develops. The two solutions to this question are Pyrocarbivory, which I've talked about before to this group, but I'm going to talk briefly about it again. And then this idea of the need for multiple species of herbivores, which is not new. It's one of the propers, but proper was never really defined, and it's often treated as should you have one domestic animal versus another one instead of sort of collectively several. Okay, so the Pyrocarbivory, as I mentioned, I've talked about it, and again, the concept is Pyrocarbivory, which is pyric is formed by fire, and then herbivory that's formed by fire. And the argument is that they are largely allowed to be coupled into a single disturbance that creates heterogeneity. So the center of this concept is heterogeneity. It's driven largely by the interaction, spatial interaction of the two, which also feed back and affect the other. So in other words, burned areas, you have burned areas within large landscapes that are not burned that year. Grazing animals can select where they forage and avoid other areas, so you allow them to behave. Where they forage is on the recently burned areas, which make it less likely those areas will have fire, but the other areas that are unburned don't have much herbivore activity and they accumulate fuel, and so you get this shifting mosaic, and that's what drives ecosystem function and biodiversity. And so the way to look at this is with some cartoons and this is going to include a whole lot of peer-reviewed literature that I'm happy to share with you if you're interested. So the idea is that in a landscape, we may have everything from a recently burned patch on the left that's got short regrowth vegetation that results in a high probability of grazing animals selecting that. And in fact, we have data saying they select it while it's still smoking often. And that lowers the probability that that will burn. On the other end of the spectrum, you have an accumulation of a lot of biomass that has a low probability of being selected by the herbivores and a high probability of being of burning because it has a lot of fuel. And the interesting thing is that in the middle, you have these really interesting plant communities that are not being burned and grazed that year, but accumulating a mixture of plants and that are unique from a conservation standpoint. And when people manage land uniformly, they rarely manage for those two middle plant communities. So if we line those plant communities up and we look at a holistic perspective of doing a lot of studies, studying a lot of different things, we can start with breeding birds. And if you look at this graphic, all of these, where they align vertically is relevant to where they are. I mean, the vertical connects to the horizontal. So for example, killdeer and lark sparrow require this 1 to 12 months post-fire, while Henslow sparrow requires 2 years post-fire. So if you want to have all of these species, you have to have this entire gradient. We've done breeding birds, then we've looked at winter birds. They follow the same way. So again, you have to have the entire gradient. Small mammals follow a similar pattern. And there's some great literature, not to give a tip of the hat to Alan Knapp too much, but Kanza has a lot of data that sort of, a lot of these ideas were originally based on. Lesser prairie or greater prairie chickens are species that actually require multiple of these elements within different life activities. And then we've studied nutrient cycling, invertebrate biomass, endangered or threatened butterflies, water cycling. We actually have some other studies as well where you need this shifting mosaic pattern in order to have all of these activities across a landscape. And we had a great graduate student some years ago, Tori Hovick, and his project, we tried to ask the question, well, how much heterogeneity is enough? And so we created this gradient where we have one patch, basically an entire 1,000 acre landscape was managed uniformly all the way to the right where the equivalent would have 8 different patches. And what we found is that diversity, I expected diversity would break off, but it kept going up. So basically, we never saw a break in the amount of diversity that was necessary, or the amount of heterogeneity that was necessary to promote diversity on that landscape. I suspect that there is, but. Devin McGranahan came along with similar data from those same 8 landscapes, and looked at the temporal variability, so the variability over time, relative to the spatial variability in the data, and found that there's this strong relationship that if you want to reduce the temporal variability, you have to have spatial variability, and that the spatial variability may be a really critical element of the way these ecosystems operate. And then from a range management perspective, we also included some studies that looked at livestock production. And so in the top left one, we found increased livestock production associated with the heterogeneity and applying fire. And this was over in a more arid system. So we got increased livestock production. In the other one by Brady Allred, we found that the heterogeneity decoupled rainfall from livestock production. So we got more stability from livestock in a livestock production scenario with heterogeneity than we did without. And then I won't spend a lot of time on this. This is some work from Heath Starnes recently that looked at lowering fire danger with pyrocarbivory versus fire alone. The main point is that recoupling those two disturbances is more effective at limiting fire than if you just use fire to limit fire. And then in the same study, Heath was able to demonstrate that you can use that to also create habitat where the interaction is critical for threatened prairie chickens, and this is across species actually. Okay, so pyrocarbivory creates heterogeneity, and that heterogeneity is important, and it does it by allowing grazing animals and fire to be recoupled and fire and systems to be dynamic in space and time. Multiple herbivores has been studied quite a bit. In fact, when I was in South Africa, Winston and Lynn took me near their home to a place that had some great studies set up. They had long-term, I think, goats versus cattle. And I think it's been well studied from a range management standpoint, but it hasn't been well studied from an ecological standpoint in general to talk about sort of energy flow and so forth associated and biodiversity associated with multi-species grazing. And we're trying to do that now. We actually have some pyrocarbivory studies with cattle only and then with cattle and goats. And so those results were 1 year into that. So what we're trying to argue in the Prairie Project is that we have two primary variables that are critical for limiting threats to grasslands, in this case woody plants, and making and optimizing ecosystem services. And the two axes are whether or not grazing and fire are coupled. So in other words, the picture there illustrates, so if you burn an area that you don't have grazing animals in and you burn it all, and then you put them in, or you decide you don't allow them to interact spatially, or maybe you don't even have fire, versus the strong coupling where it's driving animal behavior at the top. And then the horizontal axis is a single herbivore versus multiple herbivores. And the idea is that the low, medium, and high sort of talks about the conservation value to grassland systems. That the low it's still a grassland, so it's still important, but it has less value from a conservation standpoint. Medium, intermediate, and then the highest would be multiple herbivores strongly coupled with a fire interaction. But when we talk about fire, fire is a difficult subject to talk about in land management circles because a lot of land managers just sort of shut down in the discussion. A lot of the general public do as well. And there's a recent paper that I worked on with Drac Twidwell, who was a former student, where we actually argue that this social ecological interaction, how complex it's been. And we argue that we've gone through several eras. There was a coexistent era that was before, in North America, largely before European settlement, at least before the dominance of it, where fire and people largely coexisted. Then we moved into a suppression era that was sort of full blown, like the two guys on the horse, risk life and limb to put every fire out as soon as possible. And then we moved into at the same time, but later, we have what we call the shadow era, where the Alan Knapps and William Bonds and Winston Trollops are all in the shadows talking about fire, but really no one's paying much attention. And there are more people paying attention than you can imagine, but certainly that it's just a small segment of society. And then we argue that we've recently moved into a wildfire era in North America, where it's sort of like, well, you may not like fire, but it doesn't really matter what you like. We're moving into that. The point being, fire, the social aspects associated with fire are much more uncertain and relevant to the future of fire than are the ecological questions that we have. And because of that, when Dave Engel and I first published this bioscience paper that looked at the role of heterogeneity, we actually argued, we made this table, and we argued where traditional range management practices were almost entirely driven to create homogeneity. And we argued that that the right side, shifting mosaic, there could be a lot of things that could be done to create that mosaic. We focused on fire, but others could focus on more things. But to a large degree, that's been ignored to come up with alternative approaches to fire. There's a few exceptions, and this is one from Chris Helzer in Nebraska, where they've created, they've used cross fences and they've managed to create heterogeneity as shown in the illustration. And so traditionally, cross fences aren't managed in this way to promote heterogeneity. They're used to reduce it. But in this case, he's promoted it. And I would say this is really cool and very nice exercise, very good objectives and well done, but it will not work well if you care a lot about livestock production. And in fact, I don't think fences work very well when you start thinking about livestock production, which leads to the paper that is controversial I did with David Brisky, and where we found that there's very little experimental evidence that promotes rotational grazing. And I'm not here to talk about this paper, but I do get asked a lot about this paper. And I often get asked, isn't pyrocarbivory just rotational grazing? And so that's what I want to talk about here. I've created this false gradient, and this is a lot of arm waving, so I just want to promote a discussion. Uniform distribution on the left, which there's no such thing as perfectly uniform homogeneous grasslands, but that's what we're going to have on the left. We're going to have as much heterogeneity as we can get on the right, and then we're going to look at different grazing systems. So obviously there's a lot of variability, and it depends on what you mean by moderate, light, and heavy. But in general, I would say continuous grazing promotes moderate levels of heterogeneity. If you increase the stocking rate, it pushes to the left. If you decrease it, it pushes to the right, but eventually it would push it back to the left because you would have very little grazing impact. We've spent 70, 80 years in range management trying to push things to the left. And that includes the multi-paddock high density grazing that's very trendy now. Now, people will call it heterogeneous, and within a year it is, because some grass is just a little bit taller than other grass, but it's all grazed every year. And that's a primary objective. We also have some in the middle there that are other management systems that do promote some degree of heterogeneity, like the Merrill 4-pasture 3 herd, which is almost continuous. And the rest rotation starts to get even more because it can be even a switchback where you can go almost a year without grazing. And then I argue Pyrocarbivory is way over here, mainly because we have multiple years of rest. And there's some other philosophical reasons as well. And hopefully we can talk more about this. So I argue that the left is focusing on traditional management for uniform distribution and a single objective, and the right is a little bit more focused on conservation. That stock density has been largely focused on trying to increase it to the left, where on the right, at least with Pyrocarbivory, you just let herbivores decide how dense they should be. It can be low across an entire pasture because there's no cross fences, but within a patch at any given point in time, it could be fairly high because a lot of animals could be congregated, but you let the animal decide. And then finally, probably the biggest one is duration of rest. So on the left, you'll even talk about 2 and 3 times over rotational systems. On the right, we'll talk about even longer, multiple years of rest. So I argue that what we've done is go to the left, and the logic is that there's this linear relationship between forage quality in the bottom right graph, forage quality and biomass. That's actually in both of those graphs. And the logic of a lot of grazing systems is to keep that plant community right in that middle zone. And I always argue it's management to the middle. And I like management for the extremes. And the reason I do is because I don't think those forage quality and yield relationships are accurate. In fact, an example from tallgrass prairie is that forage quality and quantity, you can have one, but you can't have both. So there is no X where you have high quality and high biomass. In reality, you can have low biomass and high quality, or you can have high biomass. And so what's really important is to allow animals to mix their own diet across a landscape that includes both of those conditions. And so graphically, the way this gets promoted, this is a beef magazine. This is a very intensive graze system where they're forcing animals to graze low quality forage. And basically what it does is it leads to really poor animal weight gains unless you just supplement the heck out of them, which is expensive. So fencing animals in versus a system where you just provide a large landscape that has fire and grazing on it, and the animals can select wherever they want to go. That's the biggest difference. That and the fact that in the background here, that's a grassland that really hasn't been grazed for a couple of years. So to sort of put these up as a contrast, and I'll try and finish here because I'm running out of time. Typically proper, intensive, holistic, although I mark that out because I think what I presented is more holistic, versus the heterogeneity paradigm, single use versus ecosystem services. Distribution focus is even on the left and uneven on the right. You want no ungrazed areas in a year on the left, but you want a lot of ungrazed for multiple years, maybe even more than half of the pasture. Severely grazed areas, you want minimal on the left and we want substantial on the right. Rate of rotation, fast versus none, or slow. Diversity of livestock, typically it's single species, although there's a lot of exceptions to that on the left. Multiple species. Management model is fences versus restricted grazing access versus patches and allowing animals to select. And then finally, management philosophy, uniformity, simplicity, equilibrium, and management for the middle on the left, and heterogeneity, complexity, dynamics, and management for extremes on the right. And I think I'll stop right there so that we have plenty of time for questions.
Sam, thank you very much. That was really, really interesting. I'd like to invite all attendees to please post questions in the question and answer box, and we will take time to answer those questions. You can also raise your hand, and then we can unmute you and you can speak to us. So I'd like to start off. I have a question. What would be the optimal spatial scale of your patches? Are we aiming for lots of small patches across the landscape? So it's a bit like the protected area, single large or many small? What would be optimum?
Well, thank you. That's an outstanding question, and honestly, I don't exactly. There isn't an easy answer to that question. I guess philosophically, what I would say is the answer is yes, all of those. but that's fairly difficult, and that's been one of the problems with trying to communicate this to the public. A lot of people want to know, well, okay, how much heterogeneity and at what scale? First of all, they want to know what is heterogeneity, and I think it's a valid question. I just don't think we've done enough research to actively answer that almost from an engineering perspective. We do know that animals use patches of all sizes, and different wildlife use different size patches. Some use big ones, some use small ones. So I guess the short answer is kind of like the conservation biology and the reserve question is all of those would be ideal. But I guess one of the points that I think it gets missed in this discussion is the perspective from the traditional rangeland management perspective. And that is, the first answer is to stop trying to manage everything to be homogeneous. So rather than to get into the details yet, although hopefully we'll continue to learn more, and I'm all about trying to ask that question. And in fact, that's sort of what the Tori Hovik study, where we were trying to look at how big of a patch do we need and so forth, was supposed to reflect, but it ended up that the more heterogeneous we made it, the more the system worked. So I think the answer is yet to be determined, long story short. So thank you. Okay.
We have a question from Katlejo. They ask, what informs the influence of grazing intensity, i.e. the stocking rate, on ecosystem services and animal production?
Well, I mean, I guess the big variable would be vegetation production and the relationship between vegetation production and numbers of animals. And of course, stocking rate being including time, as well as numbers of animals and area. So the main thing would be how productive is a grassland. And that's one of the challenges with that simplified graphic that I illustrated that I meant to mention. All of that assumes that we can even measure optimum production and that will apply to another year. And that's one of the challenges with managing stocking rate, is that the optimum stocking rate would change dramatically from year to year. And David Brisky, hopefully he will talk about this. One of the things we've pondered writing another paper on is sort of just challenging the whole idea that there's even such a thing as carrying capacity. And if there is, it's certainly highly variable. But the big issue is how much vegetation is produced.
Okay, thank you. Then we have a question from Tim Hoffman. He says, many thanks for a fascinating talk. Could you please say something about how you measure heterogeneity and homogeneity? Do you use a combination of field and remotely sensed techniques?
Yes, and so the simple definition statistically is essentially equivalent to variance when you turn it into that. Most of our work has focused on patch level variance, because you can have variance. So if you put a bunch of quadrats out across a landscape and some are in different patches, then you can calculate the variance very differently depending on how you're interested. And we've mostly been interested in patch level variance, so variance of one patch data to another. But we have done that by just plot-to-plot variance as well as remotely sensed data. And I think they both work equally well. I think the remotely sensed data needs some more tweaking, but that has more promise in the future to be able to do this at a broad scale. Thank you.
Okay, a question from Alan Short. What's the uptake of pyrocarbivory with ranchers? Have you had success in getting ranchers to adopt it in the real world? And what's the feedback from them?
That's a great question, Alan. And the answer, so we're taking traditional management and sort of turning the cart over. And a lot of times people have a system that's not really set up for this. So as I've expected, people don't just immediately adopt this overnight, but we have had lots, I won't say lots, but we've had ranchers and substantial ranchers that vary from really wealthy ranchers that may be less worried about production to ranchers that are entirely based on their livelihood being off the ranch that have adopted it, and they love it. It sort of depends on where they are. Some of these ranchers have burned forever, so the burning is not a big issue, but they burn everything every year. And so that's very convenient to be, basically they light matches and may go have a cup of coffee. And now their challenge is to sort of limit fire, whereas most of the world doesn't use fire at all. So you're also faced with the challenge of getting them to use a little bit of fire. And in some of those cases, it seems to be a little more of a positive because they don't already have a system set up to burn really large landscapes. So they're willing to consider doing things very focused. But it's very different. I was raised in a culture where the only reason you could legally cut a fence was to put out a fire. So we're talking about sort of an opposite perspective here, but there has been uptake, and it's often managers that are interested in having livestock production as well as some wildlife enterprise. So that's a great question, Alan.
Thank you. Mike Peel says, why are we in a wildfire era? Are there not enough animals that are not moved in a way that breaks up the fuel load, or what?
Yeah, that's a great question. I don't think it's that there's not enough animals, because I think with woody vegetation, there's enough fuel, and with some of the conditions of these wildfires, there's enough fuel that that you can carry a wildfire without it being focused on herbivores. In fact, in the Heath Starnes study, what we found is when the wildfire conditions occur, you can't graze it heavy enough to reduce the fuel load enough that it won't carry that fire. And you can't really burn it enough to keep the fire out. That really it's hard to manage against that, short of turning the prairie over. And so I honestly think it's more to do with climate change than it is to do with the change in fuels. The change in fuels is a really important element, and herbivores can be used to modify that, but I honestly think it's more associated with us having more extreme conditions that occur that ignite these weather events.
Thank you. Now a question from Teresa. We are seeing an increasing probability of fire on grazed annual grasses versus ungrazed in the same ecosystem. As grazing intensity increases, fire probability increases. From your experience, any suggestions on where we look for why this is occurring?
Wow. I mean, that sounds like some of our western rangelands and the invasion of annual exotic grass. And I'm not sure that I don't have a lot to add to that, other than I would just say that that intensity and heterogeneity may matter in interpreting that decision, but I know that often when these grasslands switch to annual plants, you do get a more homogeneous fuel bed, and that could be a contributing problem. But that's where I would look for the answer, is some of the cheatgrass information in the West. It's a great question.
Okay, then we have another question from Johan. How would you see the management of heterogeneity and grassland quality in the increasing drought conditions setting in due to climate change?
Yeah, I think it's a challenge. I guess an important point is that I don't think it changes some of the other important things that we might do associated with increasing drought and climate change, in the sense that there's a lot more uncertainty, and we're going to potentially have to do things like just overall reduce the stocking rate. I think that's a really interesting question, and the challenge, we have done heterogeneity management through the middle of some really severe droughts. And what happens is the landscape becomes more homogeneous because the livestock or the grazing animals use even the unburned patches. So it does create homogeneity. But I will say this, where we had homogeneously managed grasslands compared to heterogeneous, we made it through the drought with the heterogeneous management, whereas we didn't make it through the drought where we homogeneously managed it. So that's complex answer. I think it's a good question, and I think it's yet to be seen. I think that would be a fun study. So thank you.
Okay, next question from Heidi Hawkins. How might these concepts apply to semi-arid or arid rangelands, such as shrublands, where fuel loads exclude fire?
Yeah, and I think that's the nature of where we started this study, and the focus on heterogeneity for management. I think there are some other ways to manage. And in the prairie project that we're currently working on, it gets over into some systems where fire is much more difficult. And we're trying to look at other ways to promote heterogeneity as well. There are some examples out there of using equipment, heavy equipment, and so forth. I think the point, I don't know the answer to that, to be honest. And I think the point is that I do think the take home that I've learned is that heterogeneity is really important. And I think it's even important in shrublands that can't support fire. It just may have to happen in a different way.
Okay, a question from William Bond. It seems as though you assume the system is reversible, so it's possible to leave areas for a few years or graze them heavily for a few years. What is the risk of getting stuck in one state, for example, in densely wooded encroachment?
I think that brings up a really good point. The Pyrocarbivory model is assuming that you are in a grassland that is not under heavy levels of encroachment, and that you sort of replicate the needed fire return interval that's necessary on that landscape to maintain that grassland. Much of even the areas I work in have already crossed that woody plant threshold, and pyrocarbivory is not going to get them back. You're basically going to have to use some other alternative method or not at all. And that the bottom line is that those areas will be, you can get them back with fire, well, arguably, but they're extreme wildfires. And that's typically what happens here is they stay in that state until there's an extreme wildfire, and then basically we try to manage the recovery of that. But often it sort of just starts the trajectory over again and becomes that threshold woody plant system again. So that's a great question. Thank you.
Okay, now a question from James Gambiza. My concern is that we spend a lot of energy debating the merits and demerits of different systems of grazing management. We should move forward by synthesizing our knowledge, e.g. through meta-analyses about the different systems. We also need to take into account the different land use systems, e.g. communal rangelands and commercial systems. Context is an important factor to consider in grazing management.
I think I agree entirely with that point. And I actually think sort of that socio-ecological perspective needs to be sort of adapted to do that. But I also agree that we've studied the micro details of this enough, and that there have been meta-analysis, and that those discussions are largely, we're just continuing to have the same discussions over and over again.
Okay, there are still a lot of questions, but we have run out of time. So I'm wondering if maybe we could send the questions to you and you could perhaps comment on them later on, because we just can't get to all of them now, but lots of questions for you still.
Sure, and I would welcome any discussion anyone wants to have. If you do have any questions, even if you haven't written them down, I would be happy to interact more. So, thank you.
That's great. Thanks very much. So you do have contact details. You can either send your questions to us, or we can pick them up out of the question and answer box and collate them and send them through, or feel free to engage with Sam directly. But I think it would be of huge benefit for the community to see the answers to that.
Agreed. Thank you.
Very much. Over to you,
Thank
Kevin.
you very much. Thanks. And thanks, Kevin.
Sam, thank you very much. It's again, I've got the easy part is just to say thank you. That was a fantastic talk. And I think you've given everybody a lot to think about. And I think there's going to be a few follow-up questions coming your way. So it'll be nice to have that interaction. And thank you very much for that. And then I'd also just like to say thanks to Debbie for chairing the session very well. Thanks to Franny for all the technical putting this together, and also for Erica for all the work in the background. And then from the first webinar that we had last month, we got a lot of really interesting feedback and good feedback and suggestions for future. So I'd like to encourage listeners to give us more feedback after this session, and also make more suggestions for speakers in the future. Our next webinar is going to be on Thursday, the 26th of November, also at 5 p.m. And that is going to be delivered by David Brisky. And the title of his talk is going to be Reflections on 40 Years of Holistic Grazing Management Assessment. I think it's a very relevant talk. It's a very interesting talk to follow on Sam's talk. And I'd like to encourage everybody to attend that one in a month's time. So thank you very much, and good night.
Thank you.
Thanks very much, everyone. Bye.
Bye.